and jump back over so that we can have this part of it in process. All right, so what we've got is I'm going to collapse this down because I don't need it. Sketch wise, the way that you want to approach parts like this is to take this and find where that symmetry is, just like we discussed. And for this purpose, I'm actually going to create this. I'm going to use the right plane, since I'm thinking of the right plane as being right through the center of these parts, more or less. The reason for that is partly because of some of the measurements that we're using, some of the overall length measurements. We'll work our way through what we need to. But the thing I want to focus on first is I want to bring this into my primary focus, as this is the part that I want to recreate on that plane so that I get the material, and whether I actually put the right plane here or here or here or here or here or here is frankly irrelevant, so long as I understand where my reference point is and why. So there's a few things that we need to be able to recreate. The first is going to be the center. So I'm going to leave this origin as the center of the object here. So I have some sort of circle at the outside. I have an outer radius that's a whole lot bigger. Because of the way that this is designed, I can see clearly that this is a fillet. So I'm not going to worry about this inner circle, because that doesn't actually tell me a whole lot. I'm going to focus on just this main outer diameter, which is measured here at 11 millimeters. And this outer diameter here of 16 millimeters. The difference between the 8 and the 11 becomes important, but later. This mimics this arc, but again, a thing that we're going to deal with later, so we're not going to worry about that right now. We're going to add it into our sketch, but I want to get some other stuff positioned first. I'm also going to zoom out and drop myself a center line to make things useful later. So again, we could focus on half, and that's actually another technique to help kind of speed up all of the things that we're working on here. So we could do that. We could cut these and work on just the half, and it turns out that's actually going to be by far the most resource efficient here, for a few reasons. So this, we have our outer arc, we have an inner arc, and for this one, because I don't remember exactly where this comes up, there's a couple parameters that I need to specify. I do in fact want this to be 90 degrees, so that's important. So I do in fact want 90 degrees. I also want to set the radius of this one to be 8. We're going to make some corrections with the smart dimension to a couple of these others. So this needs to be a radius of 11. This needs to be a radius of 6. So this needs to be 16 millimeters. That needs to be 8 millimeters. The placement of this arc needs to be a little bit farther out, so we're going to drag this out a little ways. We're also going to bring it to close to the top. We're not going to focus on exactly where it is right now. It estimates this position for us. We do want to bring this into the center so that it's associated and coincident now with that line, so that then we can adjust the position, and we'll do some final movement later. But it's, for now, we're effectively going to have a 90-degree arc if we bring it up in parallel. And as it turns out, that spacing is about right, using this little piece of information right here as far as where that radius arm looks like it starts. So it looks like it starts a few millimeters below, almost right at that curve, the difference between the inner radius of 8 and the outer radius of 11 for that. So this is going to be, it's going to be pretty close for us. Then at the 90-degree mark, this comes straight down. There's a couple features that we're going to not include from this drawing as well. So at the 90-degree mark, we're going to come down and we're going to set a dimension, and this comes up to, I'm going to not associate it with the line, but I'm going to bring that all the way across to the center line. And I'm going to use Smart Dimension to clean up the remainder here. We're going to leave this arc because we're going to end up needing some of these pieces. This, however, is not an outer extruded circle. This is actually a chamfer on the part, not even a fillet. It's an actual chamfer. So we're going to have to account for that, but we need to set some dimensions. So 17.5 is this one. This one, outer dimension is 7. This one, overall dimension is fixed based on this right here, 29. Okay, so that comes all the way up here and cuts across. So we need all of those individual features in order to be able to recreate our part here. And this will be sufficient to get us most of what we actually need in terms of extrusions, concentrics. The only other thing that we're going to need to add is this part right here, this 8 millimeter vertical line. So we're going to separate. It's going to be a vertical, but I need to set the distance between this and this to be 8. There we go. So this should meet up right here if we've done all of our other pieces correctly. It happens to, it becomes coincident with this arc. Even if you zoom in, that becomes coincident. So again, this is now, aside from a couple pieces here, this is now okay. So I've now got a line that connects all of these pieces here. I'm going to specify a distance. So I'm going to read that line. Okay, so it's now a filled volume. Of course, somebody's having connection, fun, and excitement. Always. All right. So what we've got is all of the things that we need as far as the key features are now captured in this drawing. And even though it doesn't look like it yet, there's actually an awful lot here. There's a couple different ways that we could do this. We actually don't need to do a mirror operation at the sketch level if there is a true axis of symmetry here. The main difference as far as our part is concerned is one side has these chamfers, the other side has just holes. That's really not a big deal. On both sides of this part, it's just a through hole. So we'll deal with that here in a minute. But now we need to do some extrusion and get some things taken care of. So we have on this side, we have a hole, and I think the whole depth, yeah, the whole depth is specified from that face to the, let's see, is that right? From that face, yeah, this one is a little hard to tell. It's actually a through line from the center line of this front hole to the center line of this through hole, I think is, nope, because that's 30 millimeters. And that is, so that is, or maybe that's going all the way to the front. I think that's going all the way to the front. Yeah, because that length is 36. So this is where it can be really tricky to actually show something on a drawing. From the back edge to the very front edge where this radius stops is 36 millimeters. And that's 26 millimeters to the very front edge. Okay, so we need to do some extruding, and we need to take into account some of these things. So the reason I suggested that it might be easiest to treat the mid plane as, or treat the sketch plane as if it were here, is we can start looking at this and go, okay, that section gets extruded for 20 millimeters. And as it turns out, basically everything except this rear portion here does get the exterior. So we have the interior radius, and we have the exterior diameter here. So 22 millimeter exterior diameter. We don't have that represented in our sketch yet. because the front half of the sketch has to deal with all this nonsense. And that's what we're going to focus on. So from the center line, we can get an estimation of how far these actually go. So 20 is 10 ahead of the front, because that through hole, it's a little bit hard to see, but it effectively goes all the way through to this front edge here. That's where it stops. That means that our extrusion for all of this stuff has to start. In the case of the top piece, it's right at that line. Also in the case of this front nose, that's going to start at this edge. So that's 10 millimeters from our sketch plane, unless we want to put our sketch plane here, which we can also do. So there's a couple different approaches that you can take. For the sake of simplicity on this one, I guess I can actually move the plane here and then set everything back behind that by 10 millimeters as another reference plane. That's technically okay. But what that'll allow me to do is that will allow me to cleanly add the back sketch on that plane. And I can do the last bits of extrusion from there, because the back end is far more simple than the front end of this particular extrusion. So we're going to bring everything forward. So this first top piece gets extruded out another 4 and 14, so 18 millimeters. So we're going to do an extrusion of this region by 18 millimeters. Consequently, we're also going to be extruding this region by 18 millimeters. So that's going to come forward. And the rest of these mounting ears is all going to be behind that plane. So we're not going to include those. We're just going to focus on this piece. And we'll do fillets and fancy stuff later, but we've accounted for that flat side of this piece. So this is going to go out by this first 18 millimeters. So 18 millimeters forward. Okay. So doesn't look like that, but we've already got a lot of the features of our part captured here. There's another extrusion from the same sketch. So using this trick of one sketch, multiple extrusions, much more time efficient. We're going to grab this region in here. We're going to do, instead of from sketch plane, we're going to do from surface. So from here, we have another 26 minus 14 because of this starting point. So minus 14. This guy, yeah, we'll talk about what to do about this specific region. Yet more connection related issues. There we go. All right. So we have our pieces running. We need to include this. So 26 minus 14 gives us a remainder of 12 millimeter for extrusion for this part. We also need to account for a radius of, in this case, we're not going to do a full radius of 2, but what we are going to do is we're going to bring this extrusion out for this part of it by 4 plus 1, that extra shoulder thickness. So 4 plus 1, 5 millimeter. So we're going to extrude sketch 1. This section by 5 mm. Then we'll do the filleting that we need to there. So we've got the base extrudes forward done. Now we need to work on the aft section. So this is going to have, we're going to end up doing an extrude cut for this back feature back here. We're going to end up doing an extrude cut since that's just a simple cylindrical cut. So we're only really going to need the outer diameter and the inner diameter of those two on another sketch. But we're going to put that sketch back behind the level of this extrusion. So we're going to do another boss extrude. This time it's going to be sketch 1. We've got to flip direction. It's got to be this region, this region, this region, so that we've got our whole circle represented. And we're going to skip the cutout portion here on the bottom because that doesn't actually, there's no additional circular part down below here because there has to be clearance for the physical pole that this attaches to. And that is a 20 mm extrusion. Blind 20 mm merge results, region 3. Why would that result in a 0 thickness geometry? That's really unusual. All right. Occasionally there can be some strangeness going on. I'm going to add in these contours, even though we're going to end up cutting them away at the end. That's fine. Because this arc wasn't fully defined, there was a region there where there was a technical 0 wall thickness that gets created. Long story why, but again, we've actually got the majority of the difficult part of our geometry already accounted for, and there's a reason why we're doing half-Cs, because we're not spending all of our time setting all the other dimensions and all the other lines and everything. So we're going to come in and do fillets and all the other things after we've done the rest of this. So we've now captured that. Now we need another sketch on the back here in order to capture this portion of the geometry. Then we'll need one sketch on the side to represent these holes. And then we're basically done at that point. So it doesn't seem like we're almost completely done, but we actually are. So I'm going to cheat and use that back plane. I'm going to adjust my view so that everything's square, so I'm not guessing. Center line, 8.75 and 22 diameter is our keys. So 8.75 times 2 and 22. So it's pretty close on that one. All right, so 8.75 and 22. All right, then we need to use a center line. I'm going to add an actual line all the way down to here. Then I'm going to cut those arcs. Everything's over-defined, but that's okay. So we're going to do an extrude, and then we're going to do an extrude cut. So this annular region, we need a thickness of 10 plus the radius, which is 2. So an annular thickness of 12 millimeters. So that's that region. We now need to do an extrude cut. And I could go in and undo some of those sections, but I'm going to do an extrude cut, 20 millimeters, and that brings it all the way forward to this front plane, which is actually where we want that cut to go to. All right, so now we've actually got the majority of our part. This is the stage where we've got enough features captured where we want to do a mirror for the sake of getting rid of the errors so that we don't have issues later. We're going to delete the reference point there and exit the sketch, get rid of the steps there that we're fighting. All right. So we now need, we need to do a mirror. No, not an intersect. We need to do a mirror. This is the opposite of an intersect. We actually need to mirror bodies, not faces or features. So I want to mirror this body, and we're going to mirror about the front plane. So by setting it where we did, we now recreate the other half. If we make a change in the base on the other side, because there's the symmetry along this front plane, because we have that symmetry to take advantage of, we are able to make changes to these and the base sketches, and it will get copied over and reflected to the other side. Now we have what we need in order to make a third and final sketch. So this should be on the front plane. Yeah, so this is on the front plane. That's fine. Because these are because of where these are, this one is 30 millimeters away from that one. So I'll make them the same height because reasons. I need to set the dimension here as exactly 10 so that this is fixed, so that then when I go to do the separation distance here, I'm not moving this plane away from this one or this center line away from this one. So then we have at our center line this way, which corresponds with this line, which is why I wanted it there and I wanted the geometry this way. We create our hole. Then down here, we have another one, and we set up the separation distance here, center to center, of 21.07. And we set our diameters. So the inner diameter is 3.2 millimeters. The chamfer, there's a chamfer and then kind of a fillet there. Actually it's for, no, that's what's going on. So there's a 3.2 that is this side. The 3.2 is this side because the screws physically thread into that side. This side has a radius of 4 to allow clearance and free rotation of M3 metric hardware. So a 4 millimeter diameter hole is appropriate clearance for M3 hardware to be able to take place there. So we do need the 4mm as well. And that'll make sense why when you think about the actual threading of things. So we're going to set the smart dimensions on those. So 3.2 for the inner and 4 for the outer. So then we've got one more. And this one is 4.1 all the way through, because this one is, again, just supposed to be a through hole with some tolerance. All right, 4.1. Okay, so then we do extrude cuts of, no, Y, selected contours. That region, we're going to turn into through all both. We're going to select that one. We're going to select this one. So it's going to go through everything. We're going to select that one. So through all both gives us our holes on this side where we need to do the chamfers. We need to do one more extrude cut. So we need to do, instead of through all both, we need to do through all and switch the direction. We could do up to next, cut out the second direction, but we have to remove the selections. What I need to do is simply cut out this region and this region on this side. So up to next, or blind, or through all in that direction, all will work. Up to surface will work in this case, but you have to pick this surface. Up to surface is tricky. Through all is best if you can use it. So we've now got the larger hole on this side, smaller diameter hole on the other side, and we can go around and do the chamfers and fillets. A couple of these have fillets, so we can capture a few of those. So there's a radius of 1 on these edges here, but we need to do the fillets around these corners first. So we need to figure out how aggressive those are. So those are right here. So 8mm. So we can do a fillet at the end. No, not the face. I want that edge specifically, and that edge, that edge, and this edge. So those are with a radius of 8. These are now rounded the way that they should be. those edges, now that we've got that fillet accounted for, we can round those off. So we need a 1 millimeter symmetric fillet. And it's going to be all the way around the edge. 1 millimeter fillet there. Around these edges, it's going to be a 3 millimeter. So these guys, top and bottom, we're going to do another fillet. So 3 millimeters, top and bottom. And this one also has a 3 millimeter fillet. So that captures those details. We have here a 4 millimeter fillet. So that's going to go all the way around. The fillet here is going to be 4 millimeters. So that accounts for this part of the geometry. At the back, we have a 2 millimeter fillet. And then we have some actual chamfers that we're going to need to do. So that even accounts for this geometry down at the bottom. The base is truly square. We've now recreated most of our geometry. And we've got our fillet that needs to be an 8 millimeter diameter. This is actually a chamfer that needs to happen on this side. So angle, I had specified the angle, I think, at one point, but I don't see it. So we're going to go, I think we're going to go dimension on this one. Whole lot of reasons why. And around this one, asymmetric. It can't be that thickness, so we're going to bring it back to 2 and 2. So 2 is very deep on that side. So we're going to do 1 deep. This one, however, I think we're going to have to do them individually because this one is correct. This one is not. So I'm going to eliminate these two and go back to just this one first. And I'm going to do another asymmetric chamfer on this one. And it's going to be a dimension. There we go. 2 and 1 is what I want. So that gives us an outer diameter of 11, but gives us the clearance for what's called a countersink of the screw heads on the part. So that is all of the key features. So we have our radiused ends, our radiused edges. We have all of our unusual stuff going on there. The only one we don't have yet is right here. And those need to be, so let's make sure we capture all of that detail. Right here, this is a radius of 2. So this is one more fillet of either side with 2 millimeters. And that's it. So we have now captured all of the examples of our part. So these can be a little bit challenging to do, parts that have this kind of level of complexity and detail, but they are very workable. So there's some options on how to approach them. But this at least gives you a pretty good idea how that can be gone about, how that can be done. Before we move on, any questions on this? Any questions on this? Try and make sure I can see the questions. So do you guys understand now why I like to take a part like this that seems like it's fairly intimidating and figure out what angle I can get the most symmetry out of, the most detail? This is an example of this is a part that fits into the tent part 2. So what this is this is a geometry that allows for a tent pole to attach under here with a screw thread all the way through. Then there's another one that attaches in here. So one is going one direction, one's going another direction. This is a pivot point that locks into the tent part 2 so that this can swing freely so that it becomes collapsible. So I don't know everything about the geometry. I know this is a travel limiting stop so that the when it's fully extended, it has a hard stop point. And that's what it rests on in order for the tent pole to have the correct kind of bow. So I don't actually know where this goes. I think this is the piece at the top of the tent, and I think this is, so I think the part when it's actually locked into the tent top, because that has a ramped angle, I think it sits approximately like this. So it has an attachment point that goes straight down, and then it has an attachment point that goes down to the side. So I don't know exactly what the end geometry looks like. I never got an opportunity to see that, but it's a great example of using a lot of different techniques all at the same time, and a great example of a challenging part in order to make. So this is a pretty interesting one, but it's very much like a real part. Now, in order to make this stronger for additive manufacturing, this wall thickness violates it has to be much thicker in order to have any kind of torsion applied to it. But this is a pretty straightforward design. So this is not just some like made up part. This is an actual part designed for a system. Other questions? All right. If not, we can look at the next part, the part 2. And this one has some pretty interesting geometry. Couple interesting features. So here again, we want to think about where can we use the most symmetry? Where can we take advantage of the symmetry in the material? And this one is quite a bit more obvious. So the part that we want to focus on is this axis right here. So this is a plane of symmetry, and it's an important plane of symmetry because it's going to be the same on both sides. So we only have to do half the work to get the full result. It might be wise to break it up into a pair of sketches, since some of the geometry overlaps inside versus outside, but we'll see if we have time to work through all of this. The idea is if somebody gives you a part drawing, you want to practice until the point where you can just about recreate a part like this within half an hour. Yes, that does mean you might have to do it literally 100 times, 100 different parts. So drawing everything you can get your hands on to draw in SolidWorks, gee, how would I do that? Where's the maximum symmetry? All of that becomes really important. So another new part. All right. So there's a lot going on with this one. You probably don't want to start with actually probably do want to start with this interior section, because that's going to give you yeah, that will give you some of it. Yeah, let's do it that way. It'll all become a little bit more clear. Emphasis on the little bit more clear part. How I want to do this. We have the base thickness 9.5 millimeters. So this part is going to be doable, but challenging. So we're going to need some of the other exterior dimensions of this, like 64 long. This one, you're almost going to be better off doing, and because of symmetry, you can do this again in half. That's probably a reasonable exercise for this one. For this one, because of the symmetry direction, I would use the front plane, because I'm thinking of the front plane as being this A plane here. That's why I set that as a midpoint plane, so that you could see it clearly in the dimensions. So multiple ways you could do it. I'm going to start with a center line to give us a reference point. So it comes all the way across here. I'm going to make sure I've got it at 0 degrees. And it's going to come up some certain height. It's going to come up at an angle. It's going to come down a certain depth. It's going to go back up at another angle. And then it's going to come across over here. All right. So this gives us the starting point. We're going to need a slot. it's going to be somewhere out here. I don't really want to associate it with anything else. I just want it to exist there somewhere. I need the separation distance here to be 0. Oh, you're going to make me move it manually, aren't you? Okay. So I'm going to set that so that now this point is coincident. When in doubt, step out of the smart dimension, physically drag the point where you need it to be. We will get dimensions for that in a minute. That's really not super important right now. But we do want to capture a couple of these other pieces. So from this point to this front edge is, to that front point is, especially for this center line, there's a couple things going on. This edge is actually not rounded at the front, so we can use that as a reference. This is 7 millimeters tall. The overall height, I think we've got, no, we do have the slot width that is 6. Yet more people having connection related issues. Yay for connection problems. All right. There we go. 6. Separation distance from the base, 5.65. The overall diameter of that, I think I give, yeah, total height is 5. Okay, so that is fixed in the correct geometry. We have our 7 here. We have half of our overall length, which is 32. We have half of our overall wall thickness, which is 1.5. And this one, we actually need to reverse the 1.5 to get it to go the correct direction. So the 1.5 really makes a big difference. Total height of that center piece here, from the base is about 18.26. So distance between here and here, 18.26. Total height from that edge, there is one other key measurement here. Yeah, this one, the 25.54 from the top to the base. I'm going to move a couple of these around, just to get us closer to where we actually need them. No, get out of smart dimension. So this is going to come down. All right. Nope, don't do that. Okay. So that height can now be set between this point, the top of that edge, before we do a fillet, and this top piece is about 25.54. Okay, 25.54, 1.5, that one's fine. This distance, we really probably should set this angle first. So the angle between, don't grab the center point because you'll regret certain life choices. That angle should be 155.94. That angle is parallel. That angle is parallel. This distance between here and the center point, nope. Fine, that distance needs to be 7.07. And then that pretty well locks in the rest of our geometry. We'll do a little filleting at the end once we have the 3D object. I'm going to bring this all the way to the bottom and remove the pieces we don't need here, which will undefine some of our pieces, but that's okay. Here we go. All right, so this part can now be extruded by our 9.5 as a mid-plane extrusion. This region, mid-plane, 9.5. Why 9.5 instead of 10 millimeters? Couldn't tell you why. But this is a portion of the interior. Now we've got another part of the interior that we're going to bring our another sketch to play here. In order to make that make sense, we have to reorient our view. Then we need to set a reference plane. And this needs to be referencing not really the face, but we need to reference the front plane. And we need a separation distance of, if we're going to do it from the front face, it needs to be, actually we could use that since we have this dimension. We could use this face and separate it, since we've got that dimension, by 11.25. So this is the front face of our geometry. We'll make that a little bit bigger just to make life a little easier. So then we're going to recreate this portion. And in order to do that, we're going to need to do a sketch on this plane. So add new sketch. And we're going to meet at the very top here and come across. So there's a couple geometrically unusual things that are happening here. But we note that the base of this arch really does actually start here at the top, at the center. So we know we've got some kind of an arch. And it comes down somewhere over here on the line. And it doesn't intersect with this down here, but it does something. So we're going to have to fine tune that a little bit. But we're going to get some radii from those. and that'll give us, actually, I think that one I don't specify the radius just because that would make things a little bit too easy when the real parts are being made. Yeah, actually, that one I don't give the radius for. When they give you parts for the exam, what's going to happen is they're going to give you information, but it's going to be not exactly the way that you thought it was. It's going to have almost all the information. You're going to have to estimate one or two dimensions. You're not going to have the information that you're looking for, and that's going to create much heartache and much consternation. But that's why I want to prepare you guys to be a little bit better able to deal. So this, since this goes all the way out to the full width, we know that there's a line that comes up. So there's a line that comes up to some certain height. And then there's a 3-point arc that ties it all together. And that we are given the radius of. That's a 76.64. Okay. And there's a radius of 10 here. So we know roughly where that radius sits. We can get an idea where these guys are going to be because this is another important geometric reference. So we know that those sit, there's a center line that comes up around 24 millimeters. So we're going to use a center line for that reference. From the base up here, 24 millimeters. And we know that they are separated by 34.73. So the distance between this center line and this center line here has to be half of that because reasons. 34.73 divided by 2. So we have our reference lines. We can do our the through hole again is going to be 4.1 diameter on this one. True radius of 2.05 and then 4.05. So again, it'll be a 2 millimeter radius countersink. We'll get there later. But for reference, we could add another circle and then say what the height of this object is going to be. So we know that we have an arc of radius 10. So we know that it's going to land somewhere over here relative to the circle, and we can get some sort of an idea of scale, what that might be, by going here and here and saying this needs to be a radius of 10. And then what we can do is we can drag this down because we know it needs to be a 90-degree arc that we're working from. And we need to see roughly where it will intersect to give us our geometry that we're interested in here. So we can make this coincident, but it helps to know about how high that needs to come. We know what the radius of this guy is, and it should be specified in the smart dimensions, but for whatever reason, we don't have it specified on the drawing. There we go. So we know that somewhere in this general vicinity is about correct. So we can do a 10 millimeter sketch fillet on this one because we know what needs to happen there roughly. We see about how much is left if we do a 10 millimeter fillet there. So we can eliminate this arc that was used just for testing. And we can come in here and we can do a sketch fillet. And the sketch fillet is going to be of radius 10. And that puts our angle pretty close to where we need it to be. It might need to be adjusted up slightly, but by the time we put the 8.1 millimeter diameter circle, we're going to be pretty close to the base of it. So we're in the right general vicinity for this part. It may be shifted a little far to the left. We may need to increase this height just a little bit, and we could do that by saying, this actually looks like it's intersecting a little low, and maybe this needs to be 21 millimeters or something like that. And that actually lines up our arc pretty close. We're almost at the base of that 4.1. So we're pretty close. We're probably in the right region there. So this is probably about 21, about a 3 millimeter height. If that's about a 2 millimeter separation distance here. So yeah, about 3 millimeters is in the right ballpark. All right. Also, we have another reference down here. It's about 3 millimeters. So somewhere around 21 is about right for that arc to start. And that's how you tell some of these things. Or you could look over here and say, 5 millimeters height on the slot and 9.44 to the top of the arc. So that's a more exact dimension. So we could get rid of that one and we could specify off of here 9.44. Trouble is that brings us back down here. I think we've got a little bit of separational distance issue there, but this at least gives us something to work from. Up here, this is 9.44, so it's not that dimension. So 9.44 is, yes, I know. 9.44 is this dimension right here. You have to be real careful with where these leader lines go, because if you thought 9.44 was between those two, you would be tricked. That was one of the traps I put on there. Forgot about that on the drawing. So the arc height is 9.44. So if we specify that, it has to bring it up in order to make that work. And then that position is almost exactly flush with the base as it should be of this guy. So it's almost exactly right by the base. And that actually looks to be correct. So we've got that nailed down. 5.65, we've got those taken care of. All right, so we basically just have to do some filleting of that material. We've got a couple approximations. This is a 1 millimeter radius. Based on that, this is a millimeter. This guy is a millimeter in this direction. There's another fillet under here. So this overall length is probably about, this overall length is probably about radius of 1. So this is a 90 degree and that's another, so this is on the order of about 5 millimeters before, this is on the order of 5 millimeters before the filleting. And this arc, we don't have a radius for, but we can move that without the smart dimensions. We could try a radius of about 30. We could try a radius of 32. So what we're looking for is to bring this really close to the edge here. So this needs to be 34. We're pretty close there. 35. 35 sounds right from what I remember. So that's going to get us pretty close. That's going to be enough that we can work with it. All right. So when we're done with that part, we also need the through holes on the other side. So again, we've got the 2 different diameter holes. So we've got the 4.1 for the through hole, and we've got the probably 3.8, because I think this one was designed for M4 hardware on this side. I don't remember offhand. Yeah, radius 1.85 for the through hole there. So one more 1.85. Here 1.85 radius. All right. So this gives us the other pieces that we need. We can now do the extrude. We're going to flip direction. I will need to close this part of the geometry with lines. So let's make one more change first. Otherwise, we have to do all sorts of things that won't make a lot of sense. Okay. Go. Now we can do the extrude. We're going to use we're going to use up to surface, and we're going to use this whole region. So this whole region up to the surface. We're going to hit OK. Yeah. This has a thickness. No, because this needs to be the entire wall thickness. So there's one more key dimension. We have to do another kind of extrusion here. So there's one more piece of it where we're going to need a third sketch because reasons. So 28 millimeter. There's a 15.6 millimeter spacing. That's 28 to the inside, 32 to the outside. So 32 minus, let's see, this is, this is where we do a little bit of quick maths, and we do 32 minus 15.6, and then we divide that by 2, so we get 24. Nope. 32 minus 15.6. Order of operations went correctly there, which sometimes is unfortunate. So 8.2 blind, 8.2 millimeter wall thickness. The trouble with trying to recreate it this way is we've got a few pieces that we need to bring together, and it'll work once it's fully connected. But we're going to have some work to do. So now from this surface, we need to extrude again that section, but with the smaller diameter holes because reasons. So instead of from sketch plane, we need to do an offset. And we need to do an offset of, the easiest one to do is going to be 32 millimeters. And it's going to be this region and this region, but I need to flip the offset, and that's going to give us this section. So we're getting closer, but now we have to connect this geometry in the middle, and that geometry does not include this lower portion. So what we need is we need yet a third reference plane to make this a little easier. 0 offset so that we can copy this. And we need to hide the boss extrude and hide the boss extrude so that we can focus on just this arc. We need to recreate on this plane. We need to sketch. We need to offset entities. We need to do a 0 offset. Offset, come on. Offset entities, 0 offset. All right, so we can recreate that. Then we're going to do the same things. We're going to create a line here. We said was 5 millimeters. So we'll do smart dimension there. Five millimeters. We're going to do a 3-point arc. And we're going to need to specify the radius at 35. Okay. And then trim out the parts that we no longer need. Okay, there's those. All right. So now we have a geometry that should be closed. There we go. Trim out those two. Okay. So now we have a geometry that's going to be matching up with the other components. And we're going to do an extrude. So we're going to make these visible again. Boss extrude 2, boss extrude 3. So this is what we're going to use to be able to connect those geometries together. So this is how we do a patchwork piece to make that work. And I know we're out of time and a bunch of you are going to have to jump and run. We're going to do up to body. Okay. And then we're going to do on the other side, we can do kind of a cheat. From surface over here up to body. And it's going to be this one. And it's going to be this same contour again. Only we'll do up to surface. There we go. Now we do the mirror, then the fillet, and then the chamfer, and then you're done. So you mirror this whole, rather than features to mirror, you want to mirror the entire object about the right plane. Do your filleting all the way around and it'll work much better. I think the whole thing has, again, a 1 millimeter fillet all around the edge. One millimeter fillet all around the edge, same thing on the other side. And you very quickly have captured the majority of the geometry. And here you guys thought there was no way I was going to be able to get done with the part. There we are. We've got the majority of our things. There's a couple more fillets in there that need to be done in order to match these dimensions exactly. But that is how, so including the fillets at this edge are pretty important. But that's essentially the second piece minus our chamfers for the countersink, which is pretty quick to put together because these are not super difficult to do. Dimension, asymmetric. No, I'm going to go back to angle and I'm going to drop this angle down because it's not 45 degrees. It's actually closer to, oh no, can't do both of them at once because reasons. So dimension, 1 and 2. And on that side, 1 and 2, except they're reversed. This one's 2 and that one's 1. So then we have our countersinks. So we're essentially done with the part. All right. There's a little more filleting that needs to be done there, but that gives you a frame of reference for how to recreate a part. And we were able to do that effectively within that half-hour time block. So we'd be very close to actual mass on the part now. But that's what it looks like. So any final questions as we go to close out? I'm sure there's a few. Let me go ahead and stop the recording.